By now, we know how to build the pipeline in Databricks in high level. We know what bronze, silver, and gold look like, how incremental load and CDC can be implemented, and things like that, and many more. In this episode, we'll be talking about the performance and cost and other the important topics that every Databricks engineer should know about, be careful about. So let's start with the performance. So before we start talking about the performance, I wanted to say this very clearly. The Databricks performance and cost are architectural decision, not a last minute fix like a traditional SQL Server. In traditional SQL Server, how it used to work was you create the table, load the data, add the index, fix the bug, improve later on. You know, you can do later those part always. However, in Databricks, this is you have to think about ahead of time. So performance problem come from the data layout, not from the SQL syntax. Because again, Databricks is file-based system, not the table system again. So if somebody asks about traditional database management system, what can be done, top three things for the performance, I would say indexing, partitioning, and compressioning. I would actually say appropriate index, appropriate partition, and appropriate compression. That would fix the traditional issues. However, in a modern data system, or Databricks, if somebody asks again, what are the top three factors? I would say partition frunging, file sizing, and cache uses. So let's talk about what are those three in a little bit detail. So partition frunging is another partition topics. But when you talking about the partition frunging, the goal for this is to read the list files or data. We do not want to read all the file that available in LakeDB. So we wanted to read. We need to read the data that is really makes sense. Like if I go back my LakeDB, which is S3, this is my bucket. And this bucket, if I open one of it, I have the raw file folder right here. And then as I do silver level activity or bronze level activity or gold level activity, is create a separate file to create Parquet and Delta file. If I open this one of it, it has created. As soon as I make some changes or do some modification, insert, update, delete, it create this file. So what that means is it will be thousands of file as you make a code change in Parquet format or Delta format. So we need to manage those file appropriately is our first thing. So files should be in appropriate format. That is the goal. So once we have the file in appropriate format, appropriate partitioning, then the plunging can happen. Like it will take actual file that people are looking for. If they are looking for this particular querying the data for this specific file, it's directly good and read that file. So it doesn't even scan every other file. So that is what the goal for this partitioning. So we should be careful about how partitioning thing. The another is file sizing. So another important thing about Databricks world is file sizing. So we cannot just proceed whatever we are getting. So this is right. If you are getting so many file, or if you are getting one file, very big file, both are the issue for Databricks. So the file size, right number of file size is needed. The third one is appropriate cache usage. So you can set up the cache usage, but we need to clear that with care. So we'll talk about a little bit more on right here. And then cost, if these are the partition thing, those three top factors for the partition, the performance, right? Once performance go up, the cost will go down. Because if performance the problem, then cluster need to run longer. data need to run longer. That will add up the cost. So when you deal the cost, you have to deal with performance. Once you have the better performance, then cost will go down in general. Let's take a look little detail about these partition plunging, file sizing, and cache uses. I have in three tabs for those. The first one is common partition mistake. What you do usually is we can create the partition as much as we want. We can, right? But we should not do that. Like, we have to be careful when the partition should be created, how the partition should be created. Partition should not created that never use on filter. We should not overlap the partition and small data set and things like that. So these are most common partitioning mistake that people do. The another issue on the file sizing is how much is the right file size? What is the size of file we should proceed is like art, it's not science. So if you have a too many file to proceed, that will slow your query performance, and that will generate the high cost. So too many file is like a index fragmentation in regular SQL world. If you know about this index and index fragmentation, the same thing. Like if you are getting so many file, it's just like that. It doesn't work. The third item here is the cache uses. Think about in SQL like a buffer caches. It's the same thing. When you create the cache, you have to be careful about when to set that cache. So a cache is to set for the most frequently data set, the user data set. If some data set or some file that are rarely used, you should not use the cache, and things like that. Like use only when it matters for a repeated work. So those are we should create the cache for repeated work is the thing. So these three main topics I'm going to cover as a part of again performance and cost, partitioning, file sizing, cache. And I know this episode is we are building for ETL, existing ETL and SQL engineer. So I have copied some of the comparison between existing SQL versus Databricks performance. Existing SQL, if there is something slow performance, slowness is going on, everybody think about, hey, do you need an index? Your manager will ask, hey, take a look on index, right? For Databricks world, we'll be thinking about, hey, what file can be skipped? How to skip that file? Databricks try to read all the file. So we should minimize those things. So the index versus file skipping. When you see the index in traditional system, there is this index scan and index seek. The same thing is happening on partition and prunes and full scan. That same thing has happened. You remember the DAG, DAG, that is like execution plan in Databricks. Those are something we can see these prunes in scan. So we have to avoid that as well. And for covering index, there's a file layout. And traditional SQL, bad index get higher cost, good index get lower cost. Same thing in Databricks world, good layout, lower cost, bad data layout, higher cost. Always. So we start thinking about the file layout, file partitioning, file sizing, file caching for performance and cost. And the last word I wanted to repeat again, this is architectural decision, not last minute fix. So with that being said, I think we wanted to create one last video for this series, and that last video will be talking about the final thing about this, Databricks jobs, scheduling, monitoring, and failure handling on next episode. So stay tuned for that, and bye for now.